Welcome to sitza.com. Epoxidation of alkenes. Alkenes, when you react with the peroxyacids, you get an epoxide. You see here, these are the this is the peroxide, and when you react with these peroxyacids over here with alkenes, the double bond breaks, and you get an oxygen over there, an oxygen from the peroxyacids. Now let's see what is the mechanism over here. How do we get this how do we get this epoxide from the peroxyacid and the alkenes? In the reaction here, it is the double bond, the carbon-carbon double bond that reacts with these peroxyacids, right? Okay, so it is the peroxyacid. It's like this. If I write it like this, this is the peroxide linkage. In the reaction of alkenes with the peroxyacids, it is this peroxide linkage which actually breaks, because this is the peroxide linkage is this bond is weak and it breaks over here, and actually it is the pi electrons from here that forms a bond with oxygen over here, and then you see this oxygen hydrogen bond, it shifts in this direction, electron pair, when it breaks completely, this electron pair, it goes towards this, and this electron pair, the double bond over here, it forms a bond with the hydrogen. So you get an intermediate like that. We have a carbon single bond. You can say you get the transition state like this. We have an oxygen over here. It is bonded with the oxygen with this carbon, and a hydrogen over here, right? And this peroxide linkage, it starts breaking, and you got here a carbon oxygen single bond, and you start a double bond formation there, right? And this double bond, it starts breaking, and it forms now a single bond, right? And this oxygen and the hydrogen over here, it forms a bond, right? It starts interacting with it and forms a bond, and finally this is, you can say, a transition state which is formed when the peroxides, they interact with the alkenes. It is this particular oxygen that is then finally added to the carbon-carbon double bond. You break the double bond, and what you get over here carbon single bond, and you have an oxygen over there added to the alkenes. It's like this, and you get here this R C double bond OH. So you get a carboxylic acid, and this is what you call as an epoxide. So when you react alkenes with the peroxyacids, you get an epoxide. You get carbon-carbon single bond, and it is the oxygen which is added to it, and you get an epoxide, right? Epoxides, when you hydrolyze it in the acidic medium, this epoxide it opens up, and what you get the two hydroxyl groups. So let's see the mechanism of this, how this epoxide opens up. In the acidic medium, the epoxide interacts with the H plus and forms a bond with this oxygen. So you get a carbon-carbon single bond, oxygen there with the hydrogen, electron pair, and a formal positive charge on it. And then it is the H2O molecule that's going to attack on this carbon. It pushes this electron pairs to the oxygen, so you get a OH here with the oxygen having a positive charge, a formal positive charge, and then this hydrogen is lost as H positive, right? It is removed as the H positive. So what you get the OH and OH. The addition is anti-addition. We can say it is the anti-dihydroxylation of the alkenes. So let's take one more example here. If you have a cycloalkene here, and you first react with the peroxyacids, so you get an epoxide there, you will get an epoxide here, and then in the acidic medium, when you hydrolyze it, the epoxide opens up and you get the two OH groups on the two carbon atoms. But remember, it's anti-addition, so that means if one of the hydroxyl group is, you can say if it is above plane, the other one should be written in the dashed line, means it is going away from the plane. The hydrogen here will be in the dashed lines, and here the hydrogen will be with the solid line over here. Hope you got it. Thanks for watching the video. Bye for now.